All right, in today's class, we are going to be considering unit vector. A unit vector is a vector whose magnitude is equal to 1. Unit vectors are often written with a caret symbol. So this is a caret symbol. Mathematically, unit vector is equal to position vector all over magnitude of vector. All right, so let's consider vector A. Let's consider vector A. This is called position vector. It's called position vector. And then remember, this is called the magnitude of vector A. And then this is called unit vector. This is called unit vector. So mathematically, the unit vector of A is equal to the position vector all over the magnitude of vector A. So unit vector is equal to position vector all over the magnitude of vector A. Let's take an example. All right, so if vector A is equal to 6i plus 7j plus 8k, and we are asked to find the unit vector of A, how do we go about it? Remember that unit vector of A is equal to the position vector all over the magnitude of vector A. All right, so let's find the magnitude of vector A. We already have the position vector. The magnitude of vector A. Remember, magnitude, to find the magnitude, you simply apply Pythagoras theorem. The coefficient of I is 6. So we square 6. So we have 6 raised to the power 2 plus, what's the coefficient of J? Is 7. So we have here 7 raised to the power 2. What's the coefficient of K? Is 8. So we have here 8 raised to the power 2. So the magnitude of vector A is equal to 6 raised to the power 2 is 36 plus 7 raised to the power 2 is 49 plus 8 raised to the power 2 is 64. So therefore, the magnitude of vector A is equal to square root of 149. So since 149 does not have a perfect square root, we are going to leave our answer in this format. All right, now let's substitute into the unit vector equation. So remember that unit vector of A is equal to position vector of A all over magnitude of vector A. So if we substitute, we would have the position vector is 6i plus 7j plus 8k all over square root of 149. So therefore, the unit vector of A is equal to 6 all over square root of 149 and then I plus 7 all over square root of 149 and then j. And then plus 8 all over square root of 149 and then k. So this is our final answer. Alright, let's confirm if our answer is correct. How do we check if our answer is correct? To check if your answer is correct, you simply find the magnitude of your answer. So we are going to find the magnitude of our answer. So we have a magnitude of unit vector of A. And to find magnitude, you have to apply Pythagoras theorem. So we have here, we are going to square the coefficient of I. The coefficient of I here is 6 all over square root of 149. So we have 6 all over square root of 149. And then we are going to square it plus, we are also going to square the coefficient of j. The coefficient of j is 7 all over square root of 149. So we have a 7 all over square root of 149. And then we square it. And then plus, open your bracket. So what's the coefficient of k? It is 8 all over square root of 149. So we have a 8 all over square root of 149 all raised to power 2. So this is equal to alright, so let's simplify further. 6 divided by square root of 149 all squared can also be written as 6 squared all over square root of 149 and then raised to power 2. plus 7 divided by square root of 149 all squared can also be written as 7 raised to the power 2 all over square root of 149 all squared. And then plus 8 divided by square root of 149 all squared can also be written as 8 raised to the power 2 divided by square root of 149 and then raised to the power 2. Alright, so the square root cancels the 2. And then the square root cancels the power. And then finally, the square root cancels the power. So we have here 6 raised to the power 2 is 36. So we have 36 divided by 149 plus 7 raised to the power 2 is 49. So 49 divided by 149. 8 raised to the power 2 is what? 8 raised to the power 2 is 64. So we have 64 divided by 149. Alright, so our next task is to take the LCM. Is to take the LCM. So if we take LCM, we are going to have to take the LCM, we are going to have 149 as our denominator since it is common. And then we have 36 plus 49 and then plus 64. So we have here square root of 36 plus 49 plus 64 is what? Kindly point your calculator. So 36 plus 49 plus 64 is 149 divided by 149. Remember, 149 is our denominator. So here we have 149 divided by 149 is 1. And the square root of 1 is 1. Now remember the definition of a unit vector. A unit vector is a vector whose magnitude is equal to 1. So the magnitude of the unit vector we found is 1. So therefore, our answer is correct. The answer we got before now is correct. Alright, let's take another example. If vector x is equal to 8i minus 3j, and we are asked to find the unit vector of vector x, how do we go about it? Alright, first of all, let's find the magnitude of the vector. So we have here magnitude of vector x is equal to find magnitude, simply apply Pythagoras theorem. So the coefficient of I is 8. So we have 8 raised to the power 2 plus the coefficient of j is 3. So we have negative 3 raised to power 2. So the magnitude of vector x is equal to square root of 8 raised to power 2 is 64. And then plus negative 3 raised to power 2 is 9. So therefore, the magnitude of vector x is equal to square root of 73. So the magnitude of vector x is equal to square root of 73. Remember that unit vector of x is equal to position vector of x all over magnitude of vector x. Alright, so now let's substitute values. So we have a position vector of x is 8i minus 3j, and then all over the magnitude of vector x is square root of 73. Alright, so the unit vector of x is equal to 8 divided by square root of 73, and then I minus 3 divided by square root of 73, and then j. So this is the unit vector of x.